really quick introductions for ourselves, and then we will move into our presentation. So I'll pass it over to Jay.
Hello, everyone. My name is Jay Meszar. I'm a solutions consultant here at IMAGINiT. I've been in the engineering field for over 25 years. I'm a certified Autodesk certified instructor, a civil 3D professional, and what all this means to you is that I have the opportunity here at IMAGINiT to really dive into a lot of our high definition scanning and reality capture technology, as well as Autodesk's reality capture technology and how all this works with the Autodesk products. We are a Leica Geosystems high definition scanning and software reseller. So I get to play around with a lot of that data as well. And of course, as I said, civil 3D professional, as well as teaching the AutoCAD products. So cool. Vince, go ahead.
Cool, thanks Jay. And hi everyone, my name is Vince Daniele, and I am a Building Solutions Division team lead here at IMAGINiT. I have over 15 years of industry experience. My background personally is in architecture, and I've always had a passion for design and visualization, which really plays a role in this presentation. I'm also a ACI or Autodesk certified instructor and professionally certified in Revit, AutoCAD, and 3ds Max. My areas of specialty with consulting work and training are all things related to BIM, ArcViz, Revit, 3ds, Twinmotion, which we'll be seeing in this presentation, and a whole bunch of other stuff. So to get into the presentation now, Jay is going to do the first part and kind of introduce some ideas about reality capture and point clouds. And then I will pick up from there and talk about the sort of the visualization workflows. And then Jay and I are both going to demonstrate some of the technology in action. All right.
All right, thanks, Vince. So where I want to begin is, what is reality capture? And I know a lot of people kind of think, oh, that's just a silly question, but there are also a lot of folks out there who don't get to deal with reality capture very often. And so I'd like to explain a little bit about what reality capture is. Reality capture allows the design process to happen in context to the surrounding conditions. And what that means to you is that those surrounding conditions, you're seeing those in real space, and not just in a couple of measurements that somebody took, right? We're talking about being able to capture this data with many different tools. One of those tools is 3D laser scanning. Another is aerial LiDAR. Of course, there's photogrammetry for all the folks out there using drones. We have mobile LiDAR, ground penetrating radar, sonar mapping, and yes, for those of you who are still doing it, even a tape measure, a piece of paper, and a pencil. So what we're saying here is that really anything you're using to capture the existing conditions around you is reality capture. Good, thank you. And so when we capture that data and we convert it into a point cloud, we want to talk about what a point cloud is. And I think this is a pretty good explanation that, you know, a point cloud is just a set of data points. It is exactly what it says. There are many points in space that represent the space around it. So each one of those points has an X, a Y, and a Z coordinate, right? They can be produced by many different objects. Sometimes they're produced by 3D laser scanners, sometimes by photogrammetry, right? Sometimes they're, you know, just something as simple as a, you know, regular cell phone and camera. And I'm sure folks have seen the new apps on the iPhones and the iPads, where you can do LiDAR on those, right? Any way we look at it, we can convert that into a point cloud, right? So we want to be able to create meaningful data workflows. The points can be used just as a point cloud, right? Just in their native format to create measurements. We can turn that point cloud data into modeled objects, whether it be intelligent modeled objects in Revit or maybe even just AutoCAD cylinders. And of course, the point cloud data can then be modeled into a BIM deliverable. Okay.
Cool. Thanks, Jay.
Yeah.
And just to highlight a little bit of what one part that Jay mentioned in an earlier slide with point clouds, we also have this process of photogrammetry. So really, photogrammetry is a science of taking a whole bunch of different pictures of 360 degrees, sort of an orbit around an object, and it gathers all of that photo information, and we have different programs that we can use to stitch that together to actually create 3D objects. So we're starting to see more and more of this in the industry, especially with ArcViz, but there are also applications where we can use photogrammetry, like Jay mentioned. We can actually deviate a point cloud from some of this technology. So you don't have to pay for, some crazy expensive laser scanner if you're not looking to get that sort of finite accuracy that you would get from a professional grade scanner. We can use high definition cameras. We can use things like GoPros to capture this data. So all of this with photogrammetry, it's just a different way of capturing reality and being able to produce things that we can use in visualization, in different types of maybe 3D studies. So I like to just kind of relate this to if we're using this in the building industry or the building world, we can capture, like Jay mentioned, with aerial photography, we can capture a surface, we can create a mesh from that. The important thing that I want to talk about in this presentation is the different use cases or the different ways at a macro scale and then down to kind of a micro scale that we might use some of this stuff. So just in general though, with photogrammetry, when we do create these surfaces or these models using photogrammetry, what we get is a mesh surface or several, thousands and thousands of mesh surfaces that create the object. One thing that's really important to understand is the mesh density or the resolution of the mesh, and I'll show that in my demonstration part. But when we do this with photogrammetry, we do have the ability to make a very dense mesh from the photos that we're taking and put that into programs like 3ds Max, or there's a couple others that I will mention on the next slide. But ultimately, the density is important because we need to know how that impacts the performance on our computer, but also if we're going to share this file out, we don't want to bloat file size if it's unnecessary. So these types of file formats between point clouds and high density mesh objects can get rather large, and we're talking, especially with point clouds, you can get into terabytes of information. So being able to manage that type of data is a very important thing that we need to consider. And then just finally, the last slide that I have before we go into our demo here, different solutions that we have. So for reality capture, you might use a laser scanner, you might use photo techniques to create the point cloud, but then we need to aggregate, we need to use different software to produce the data that we're going to leverage throughout our design process. And on the left here, here are some of the reality capture programs that are out there. The Leica 3DR is a good mesh creation program. Leica CloudWorks is a nice plugin for programs like AutoCAD and Revit, where we can take a point cloud into those programs and actually build off of it or create 3D geometry natively in those programs, or 2D geometry in the case of AutoCAD, but inside the program. So there are specific tools from Leica CloudWorks that allow us to do that. Some of you may have used Recap in the past, or for also bringing the point cloud into an Autodesk solution that sort of packages it up into a usable format that we can put into programs like Revit. Pix4D, 3D Zephyr is a really nice photogrammetry software, and it's free. So if you haven't checked that one out, I recommend. If you're interested in some of the stuff you see today in photogrammetry and actually creating these mesh surfaces, 3D Zephyr is a nice program. In terms of visualization, in the Autodesk world, we have 3ds Max, Maya for mesh editing. There are other programs like Alias. What's the other one for manufacturing? VRED for visualization. Outside of the Autodesk realm, and something that a company that we're partnered up with now, Epic Games, they produce the Unreal Engine. So we're starting to see a lot of these techniques, and one of the highlights of my demonstration will be showing how to take information from Quixel Megascans, so the last bullet point I have here, and bringing it into 3ds Max, into Twinmotion, and then ultimately we can build that into the Unreal Engine to get to augmented reality and other forms of virtual reality. Okay, so with that, I will turn this first part of the demonstration over to you, Jay, if you want to talk through the reality capture solutions.
Okay.
And you should have presenter now.
And you're seeing that okay?
Yep, got it.
Floor plan?
Yes, sir.
All right, thank you so much. So what we're going to take a look at is just a small piece of software, because one of the questions that we often get about point clouds is, well, this is great. I get this point cloud, and what do I do with it? What can be done with it? And the software I'm looking at right now is just simply a viewer. It is allowing me to view a point cloud, but there's a little more I can do with that point cloud. So if we take a quick look, we can see that all these little red dots are where my scans were collected. And of course, then they were all pieced together and put out into, in our case here, an LGS file, where I can hand that to anybody, and I can share this via Dropbox or anything like that, Google Drive or whatever. And anybody can open it with this free viewer and simply double click on one of these scan locations. And then as you can see, we can go from scan location to scan location simply by double clicking on that scan location. Now, obviously, I'm looking at a little more than just a point cloud. I'm looking at actually a point cloud as well as the imagery taken from a 3D laser scanner. So by looking at both of these, and let me turn them both on, and you'll see it gets a little pixelated, right? Well, this pixelation allows us to then go ahead and do things like grab a dimension where we can simply pick on points, and we get a distance along that location, right? We can click off of that, and we can create another dimension from somewhere to somewhere else. And this is a really helpful tool just to be able to grab dimensions. One of the things we don't do here, right, is we don't get on a ladder. We don't climb up here to have to pull a dimension. We can get that dimension simply by clicking and running a scan from the ground. And just to kind of add on to this, you know, more of what we can do, and one of the things I think I hear quite a bit is, well, okay, you've done that, and that's fine, but what about, what else can we do with this? What about all the extra data that you have here that maybe I don't want? Well, there are ways we can collect all this data and simply get rid of some of it. We can come in and we can create something where we might come in and select this cube that you see, and we can then edit the different sides of this cube to pare down what we're looking at. And then I can accept that. And now I've pared down all the data that I only need to see. And so this is great. But, you know, a lot of times we hear, well, geez, there's got to be something more we can do with this. And of course there is, you know, but there's a lot of different software out there. Well, maybe I've created a model and I want to be able to see my model with this data, with this point cloud data, without having to purchase a lot of software. Well, what I can do is I can come over and I can grab things like an IFC file, and I can drag and drop that. And as that imports, I'm going to come back and I'm going to dump that right in using the model coordinates, and we can go ahead and adjust our model. Oh, bear with me 1 second. Mine decided to kind of fail on me here. All right, mine failed on me, so my mistake. I'll have to restart my viewer.
So Jay, you mentioned with that point cloud, using it in different applications and creating a model from it. And I know we didn't have, we can't show everything as part of the workflow in this presentation, but can you just kind of explain what the process would be of taking this point cloud into a modeling authoring program like Revit and maybe making it a parametric model, as opposed to right now, really what we're getting from the point cloud is a really great, accurate measuring tool, right? I mean, essentially,
Right.
That's what we're looking at. So,
right. And to take it into something like Revit, there are softwares out there, for instance, CloudWorks for Revit, that allow me to bring the point cloud in and then use my point cloud to be able to create walls, doors, windows, piping, steel, structural steel. And right in Revit, creating Revit objects by converting the point cloud over to those types of objects. And I got my model in here. It just needed a quick little reboot. And so I have my model over top of the point cloud. And now again, using a free viewer, I can then go ahead and I can fly through, giving anybody a tour of my model data with my point cloud data.
and that model is just brought in via an IFC file exchange back into JetStream.
Yeah, just drag and drop.
And that was created from, let's say, Revit could have been the tool to create the IFC file.
It was, yes.
Awesome.
Yep.
Cool. I will go ahead and let me see if I can do this here. I'll take the presentation back over. All right, show my screen. So a big thing that we want to kind of communicate to everyone is that, you know, with point clouds and with, is this sharing? I can't tell if this is sharing.
It is. I see your Quixel.
Quixel Megascans. All right, great. So one thing we want to kind of communicate to everyone is that with this process, yes, we can use a point cloud to create that really enriched 3D model that's accurate and is capturing that real situation. And I know a big theme of AU this year is this idea of a digital twin. So obviously when we do our a ground up design in construction, we might do the model in Revit, but then once the building is built, we don't really know, we don't really have anything to verify that it was constructed the same exact way that we designed it. So having a point cloud and reality capture techniques we can actually start to produce an accurate 3D model to the as-built to real-world condition, which is a really important theme. And we actually have a presentation later today, which we're going to cover that and how it relates to facility management and digital twins later on. For the sake of this presentation, really we wanted to highlight the visualization side of it. So with what Jay was showing, those tools in Jetstream, just from a scan, even before you get into modeling, if you need to convey ideas or walk through a space and talk to an owner about it, kind of even look behind the walls or in the ceiling, we can scan that data. We can pop ceiling tiles out. We can scan above the ceiling. Using that sectioning tool that Jay was showing you, you can start to communicate the building, the existing building, in ways that you can't really do with a floor plan or a CAD drawing, even if it's an as-built CAD drawing. So to kind of pivot then to more of the visualization side and how this technology is being used for conveying more, I guess, a virtual idea, maybe not directly from an existing condition like Jay was showing, but using photogrammetry and using laser scanning, we can also produce pretty realistic looking objects using these techniques. So one of the companies that's actually partnered up with Epic Games and has quick links into the Unreal Engine and to Twinmotion, this company Quixel. And one thing that Quixel has, or a product that Quixel has, is called the Quixel Megascans. And what Quixel Megascans really is an online repository of all different types of scan data, whether it's surface maps and materials or actual 3D assets. How they're gathering that, or how they're creating that repository, they're sending teams of people out into the field using photogrammetry, so really high definition cameras to capture the data, and then they're building 3D assets and they're building surfaces and things from it. So I just like to point that out. This is pretty cool, and what I'll show you here in the next few minutes is all gathered from the Quixel Megascans library. So they do have a plugin or a separate, I guess, application. You can download these Megascans right from the Quixel website through their products, so we can browse Megascans. Since we've partnered with Epic, we're selling Twinmotion as a great ArcViz tool, and something that you get automatically with the purchase of Twinmotion is unlimited access to the Quixel Megascans library. So, and they're constantly adding different assets to this repository. So we've got over 14,000 assets. You can browse them. They're 3D objects, plants, surfaces, decals, imperfections, brushes if you're a visualization artist. So, and they're constantly expanding this library. So for my example, through the Quixel Bridge, which is just a link to the Megascans library that exists as a desktop application, I pulled this little statue, this Roman statue, pretty detailed. When you go to download something from the Megascans library, you have the option. Let me see. I think I pulled the screen cap, but I don't need to because I have it right here. We have the option when we go to download, we can download different levels of detail for that 3D object. And as you can see here, it's kind of probably opposite of what you would think. An LOD 0 is the more detailed mesh, and the LOD 5 is less detailed mesh. So what I've done here is I've downloaded this as an FBX file right from Quixel Megascans. It does come with the material and it's mapped correctly to the surface. So when you go to download from Megascans, you get not only the 3D geometry, but all of the different texture maps that you would need to create the material to assign to it. And what I did here was downloaded it, plugged it into, or I imported the FBX into 3ds Max, just to show you, I'd mentioned earlier in the PowerPoint, the different levels or the different mesh densities that we can have. One great thing about Megascans is it gives you those different levels of detail, and you don't have to use modifiers in a program like 3ds Max to simplify the mesh. But the other great thing is that other programs like the Unreal Engine, when we create augmented reality levels or projects, or virtual reality levels or projects, we have the ability to bake in different levels of detail into the same object. So if your computer can handle it at high performance, then it's going to use, the most dense option available. If it can't, or if we're moving far away and the detail is not required, we can build into it a way to kind of simplify that mesh. These are all techniques that have been used in the gaming industry for a very, very long time. So you know that if you've done any gaming, that from like a distance, things can kind of seem a little bit granular, but then once you get right on top of them, they have this nice like gradient refreshing, and then they look more detailed. That's what we're seeing here. We're basically grabbing a real mesh, creating a 3D object from it. I just like to show this because it kind of shows you from that LOD 0 all the way up to your 5 what the mesh looks like. But then also, because of the way that photogrammetry works, we're not just capturing surface detail, we're actually capturing that image detail that's on that surface and creating a really robust, nice texture map and material ultimately that we can assign. So I'll just switch this over right now. You can kind of see, if I zoomed up on this, yeah, the mesh looks really nice. It's pretty dense in the folds of the statue. As soon as I actually turn on the material, let me turn off the wireframe override here. I mean, these things start to really look realistic, especially when you put them into context of an environment. And you can pull some tricks. Maybe you don't need the most dense mesh object when you're bringing it into your ArcViz scenes. You can get away with something maybe at a lower level of detail, but with the right texture map. Those texture maps are pulling a lot of tricks with the shading to maybe not simplify the mesh, but take a less dense object, that has a lower impact on the performance of your computer, but still give you that same nice realistic visualization. So you can see here that between the really dense object and the final one, yeah, we can start to see some degradation there to the objects, but not really that much. So this is something we always want to keep into consideration when we're bringing in assets or when we're creating assets, to make them lower poly so that they perform better. Frames per second or frame rates are extremely important once you start building your VR projects. So this is something that you need to kind of be aware of and pay attention to. Now, just to kind of go over into the next phase of actually creating the visualization from this stuff, or actually, one last thing I kind of like to show here is that as this is a mesh object, should already be converted as a mesh. I just like to show that, yes, once we bring it in, even as a scan, we do get those points, and we can manipulate in a program like Maya or 3ds Max. We can start to manipulate that mesh and actually edit it too. So if we wanted to do anything or clean a mesh up. So fortunately for me, I grabbed a nice cleaned up mesh from the Quixel Megascans library. But if you were capturing your own surfaces using photogrammetry and then bringing them from like a Zephyr into 3ds Max, you might need a program like Max to clean it up. And you can absolutely do that with the tools in 3ds Max. So yeah, fortunately for me, there's not kind of I don't know, floating data or floating surfaces. This is all nice and clean. But if it wasn't, you could clean it up and save those out as FBX assets. So let me just conclude here. I'm going to jump over to Twinmotion. So I mentioned that this is a program that we're now supporting from IMAGINiT. The Twinmotion program is built on top of the Unreal Engine. So it's basically an intuitive architectural visualization program. It competes with Lumion and Enscape. It does have direct links to Revit, to ArchiCAD, SketchUp, Rhino that are available. But basically, we can use those programs, like kind of tying this all back together. We can take a point cloud, bring it into Revit. Using a program like CloudWorks, we can create a 3D model from that. Then we can bring our 3D model, if we want to make a really nice visualization, we can push that into Twinmotion, start to assign materials, different assets to the space to start to visualize that space. So as you can see here, this is the statue that I brought in. I can add this to my Twinmotion library as well, which is pretty cool. In other demos, I've done this before. I think I grabbed, like this statue bust that I can bring in, and let me just rotate this up real quick. I'm not really sure why it defaults to laying flat on the ground, but let me do this. There we go, and maybe scale it up a bit. But you can see, using the same techniques as I kind of went through in 3ds Max, we are able to grab these. It's a little crooked here, but we're able to grab these assets like this one I brought in here, just import them into Twinmotion, assign the materials using techniques in Twinmotion, and then we can build out our own custom library. So it's a really quick procedure, really nice, gives a nice result. Kind of relating back to the LOD that I mentioned earlier, on my computer can't handle the most dense meshes. So what we're seeing right now is actually set to a medium quality, and I'm running at a pretty good frames per second right now. On my screen, I'm running about 60. If I change the quality of this, kind of bump up the mesh, my frames per second rate when I go to high quality starts to drop. This is a very blank scene. There's not much going on in here. We don't have a whole bunch of assets, and I'm running at a pretty good frame rate. We want to keep within probably that, around that 30 frames per second is a good threshold when you have really large scenes. They actually recommend in virtual reality that you run at around 90 frames per second if you have a building that you're trying to show. So obviously with my computer, I'm tapping out everything, my resources, my GPU at 100%, my CPU at about 20%. The better your computer, it's still going to run 100% GPU, but it's going to run it at a much higher frames per second. So some of the latency and some of the issues that you might get in VR when you put a headset on, like a Vive or a Rift or whatever headset that you're using, you definitely want to be at that sort of that higher threshold of frames per second. And that's when that density of the mesh comes into play. So I did have, and we did this presentation a few weeks ago, I had a scan that the RCS guys, Jay and Jeff from our team, gathered of one of our offices, and I showed that model in here that was brought in from Revit, being modeled from CloudWorks, and started to put objects. But in general, this is the idea of taking scan data, bringing it into visualization, and there are many different uses. Twinmotion just gives us a really quick way to get into a presentation, rendering, or right here, this button for virtual reality. So I think that kind of concludes what I had to talk about. So I will go back to our PowerPoint here, so from the slide. So I'd like to say for myself and Jay, thanks everyone, and we'll open it up now to questions.
Okay, can you hear me?
Yes.
Okay, never know if I've double muted myself. Okay, thank you so much, guys. There was 2 questions that came in. One is, we are a smaller manufacturing company looking to capture as-built pictures or models. Is there a process or equipment to look at for this purpose? Truck-sized projects.
Let me see. What size projects?
Truck
size projects. Jay, you still here, or did you have to drop off?
No, I am here. Well, I guess my question would be back to them. Pictures, if we're looking for 3D pictures, there are a number of items on the market that can do big 3D space pictures. If we're actually looking to create point clouds, there are a number of smaller scanners on the market that would probably fit the bill. So hopefully that answers the question.
Okay.
Is that the question from Peter?
Yes.
Yeah, and so the other the other thing I'd say is that we at IMAGINiT, we support the Leica workflow, the Leica software. So I would say there's both process and equipment that we would recommend. So you could have the most high-end laser scanning equipment on the market, but if you don't have the correct software to process it, then you're really not doing it justice. So from Jay, from your perspective, I know that we sell Leica software and we stand behind it, but would there be, for taking, I guess, a scan and putting it through, I guess, what would the software workflow look like? Would that be, I know you could use Recap, but we probably wouldn't recommend that, but to register the point cloud and then to bring it into something like Jetstream Viewer or Revit, what would that workflow look like?
Yeah, for the project size they're mentioning, the workflow would be take the data from, and if I'm understanding what they want correctly, through a BLK 360 and over to an LGS file. And then you could take that LGS file into, depending on what you want to do with it. If you want to create a mesh like you're doing, you might create it in Cyclone 3DR. You might create it in one of the meshing softwares that you mentioned today.
Awesome.
Okay. So one of the comments earlier on was, wow, this is way over my head. It sounds super useful, but I need an introductory class. So I read that comment, and so in the chat, I don't know if you guys have access to it. GoToMeeting is fairly new to me. We have a resource center on our website that I absolutely love because it's not just a PDF that you may or may not read. So I have two links in there for you. One is the virtual reality link, and that gives you past webcasts, white papers, everything you need to know about the virtual reality part. That's the Twinmotion. And then we've got the reality capture, and that's everything you need to know on scanning. So hopefully you guys have access to those links in the chat field. Okay, going back, another question. Do you have experience in using drone, I'm hoping I say this right, photogrammetry as existing conditions to bring in as context in Twinmotion for new construction? Any tips on converting to a measurable mesh size?
Yeah, so this is a big one for sure because and I assume with drone with photogrammetry, we're putting like a GoPro or something on that drone and scanning a site and mapping a site out. Jay, do you want to speak to that side of it, and then I can maybe relate some of the techniques that I would use to take a very, very high density mesh down to a usable level for something like Twinmotion.
Yeah, when it comes to photogrammetry, the end output really depends on what you're using to create it with. So that old saying applies: garbage in, garbage out, right? So if we're using let's say, hobbyist drone with just a so-so camera on it, our output and data is not going to be quite as good as if we are using a drone with a very good camera on it. And so there are a number of softwares out there to process that drone data once you find the hardware you want. One of them being, I believe you mentioned it earlier, Vince, was Pix4D. There are a couple of others out there, Drone Deploy, and even a few others that don't come to my mind right now. But everything has to do with the settings in those softwares to process that data out the back end to get it to something like Vince is using in Twinmotion.
Yeah, and one of the things that I've found in my experiences with some of these really large site surfaces that we might be capturing, and whether it's using laser scan or photogrammetry, there might be times where there is a certain section that's missed because of shadows or because of just maybe like puddles reflecting light. I know that with scanners, that's always an issue. So sometimes after you've scanned the object or created photogrammetry, there might be issues with the mesh. There might be holes in it or kind of sharp points here and there. So one thing I like to do is, for the sake of visualization, one great thing about photogrammetry is that it is creating that nice image that we can overlay on the surface. So we can kind of cheat a little bit. We don't have to have that super dense mesh. So what I like to do is I'll take that raw data, and like Jay mentioned, we can create the mesh from Pix4D or a number of other programs from using photogrammetry techniques to create that mesh surface. Bring it into a mesh editing program like 3ds Max, and I'll just kind of use it as my background or as a reference. In 3ds Max, we can create a plane, whether it's an editable poly or an editable mesh. And the difference between the two is editable poly uses quad surface, so 4 points to create each little square along the surface, and a mesh is triangles. So triangles tend to have a better, I guess, shape to them once you lay them over one of these scans. So I would probably just create a plane, make it an editable mesh, and then using 3ds Max, there are some techniques where we can basically drape that object over the surface to create a nice softer gradient where it will kind of correct some of those mistakes that we might get with the scan. And then we can get into kind of a more granular level of detail and clean up some of the vertices and some of the edge components within the mesh. So there's probably a level of editing that needs to happen to kind of make that less dense. There are modifiers in 3ds Max, like the Pro Optimizer, that you could apply. The problem with those is that they're just going to degrade the mesh, and if it wasn't looking good in the first place, it's taking more triangles away from it, so it's just going to look worse. So that's kind of why I like to use maybe a technique of draping over the surface. And then, because it's photogrammetry, with that draped surface, we can apply the surface material or the surface map to that new surface, and it's going to look really nice. So just kind of, I don't know, a visualization trick that I would recommend. And it looks like we've got one last question in here. Small architecture firm, can you talk about the process of point cloud to Revit, specifically in mapping an as-built condition to Revit model elements? So to answer this one, and we mentioned it a few times, there is a Leica program called CloudWorks that plugs into Revit. What's great about CloudWorks is not only can it actually use algorithms to extract point data and make it into Revit components like pipes, steel, walls, windows, but it also can manage the point cloud in a much better way than we get with the native Autodesk tools in Revit. So if you've ever brought a point cloud into Revit, you know that it's going to really hurt the performance of the model when you bring it in, but also you can only usually bring in chunks of it at a time, the RCP files, and you kind of have to manage turning piece by piece, turning them off. The CloudWorks tools have their own sort of back end that works to process the point cloud, and it actually does use, I believe it uses some type of gaming engine to process it, but we can view the whole point cloud in Revit and move through it much quicker. But there are also those tools where we can click a few points on the point cloud, and then it automatically looks at the surrounding points to generate lines that we can then build into walls. You can gather a cylindrical group of points to create pipe, or I think even now there's conduit in there. Jay, I might be wrong on that.
Not conduit, not yet. No,
not yet. So
just pipes, walls, doors, windows, structural steel.
But you can do, if you, I don't know that conduit would be that big of a deal anyway, but if you had a cylindrical grouping of points, there is an option to create a model line down the center of that as well, right? So we could always take a model line in Revit and then use that model line to create whatever system run we're trying to Not that that would be that important to an architect asking the question, but the tools for creating walls and stuff are pretty simple too. You basically cut a nice slice of the point cloud down, look at it from an overhead view, and then you basically start clicking on different corners along that point cloud. It generates almost like a polyline from it, and then we can use those polylines to create walls. IMAGINiT used to have a utility called Scan to BIM that was really great and did a similar thing, but we stopped supporting that a few years ago. So,
okay. So there is one more question in there, Vince. I don't know if you see it.
Oh, what is the level of precision one?
Is that, oh, did you just do that
or
one?
did we? Ratio. Oh, no, I've got it. Okay. So what is a level of precision you typically work with in the scanned model? How much rationalization of dimensions end up happening on the built Revit model? That's a good question. It's the level of precision depends on the hardware that you're using to capture the scan. So if I were to rate it out, photogrammetry would absolutely be on the sort of the low quality of precision. And then Jay, would you say maybe like the RTC or any other professional grade scanner on the market would be sort of to the high end of precision?
Yeah, and those vary as well, right? There are the lower end, as far as at least as far as Leica is concerned, is the BLK 360, and then they go through the RTC and then up to the P series scanners, which can get really, really tight tolerances as far as scan data.
Yeah, so to answer Mary's question, how it would probably apply to Revit modeling, a lot of the customers that we've worked with in the past probably 5-6 years, architects and engineers that are working in buildings, they might not necessarily need that extreme level of precision that you would get from like a professional, like a P40 level scanner that costs an arm and a leg. The BLK series of scanners from Leica is at a more affordable price point. I think what's the accuracy? I think at like, I don't know, Jay, you guys know these.
It scans at a density of 1/4 of an inch over 30 feet. So if you draw a big circle, a 30-foot radius circle around it, we're getting a point every 1/4 of an inch around that circle. And then of course, the closer we get to the scanner, the more points and the closer together they are. Further away from the scanner, the further apart they get. And when they start to get further apart, we add more scans to cover in any of that data that it may be missing.
Right. So it's a tough one to answer in all situations, but I would say for architectural applications, if you're trying to capture where correct locations of walls, windows, doors, ceilings, floors, floor drains, any architectural element, a BLK is probably an adequate scanner for doing that, and then bringing it into Revit using CloudWorks and modeling from it. How much rationalization of dimensions ends up happening on the built Revit model? There's a few other things that kind of weigh into that as well, and I think it goes into how the collection of scans is registered. But ultimately, you're going to get, because of sort of the average of points that you're getting on a surface, you're getting down to, I don't know, what would you say, Jay, like 16th inch precision inside of the Revit model with a point cloud, probably even more precise than that. But
I was gonna say, depending on how many scans you do.
Yeah. So with scanning, there's a level of overlap that occurs when you register the scan. So the more scans that you have, the better the point cloud is going to be, the more accurate the measurements are going to be. So I don't know if that answers the question completely, but how much?
That was great.
But I
Okay.
would say, yeah, any of the hardware that's really out there in terms of a laser scanner for most architectural purposes is going to give you much, much better accuracy than, if you're measuring even with laser measurements or um, tape measure, paper, pencil.
Awesome. I want to thank everybody for asking questions. We love